Let us apply this decision tree technique to a recruiting problem. Rolling Rocks, a new startup, is looking to bring in a partner with some additional skills. The purpose is to give some impetus to the business in any way possible. Model this problem and help management to explore the impact of the uncertainties on their hiring decision. They have the following information on shortlisted candidates. Mary, she is a workhorse. She keeps things moving and motivates others. Susan is very creative in setting up processes and has a good track record to back up her expertise. The third candidate, Jane, is an amateur inventor. She has 3 inventions to her credit. The general view is there is a 50% probability that her new inventions would add $11 million to the company's bottom line. The sketch for this problem is very simple and very typical of a 3D problem. Let us proceed to the decision tree. Here we have the decision tree for the 3 candidates. You can see the poor, average and high performance, low and significant process improvements, and no new inventions and inventions. And here I have tied the 3 probabilities, orange, plum and olive, to each of these. The terminal values are as shown here. Let's move on to the D-zone map. Here we have the D-zone map. The first thing to do is assign the decisions. Mary, Susan, and Jane. Here the labels have been assigned and plot. Here we have the 3 zones. This is Susan. When we cross over, we have Jane. And this, of course, will be Mary. As you can see, most of the region is actually for Susan. We started off with 50% probabilities, and under this scenario, Susan is the preferred candidate. However, we can see a 10% change in our confidence of Susan would change the decision. Under this scenario, we have all 3 options present. But watch what happens when the third plane, which is not visible here, is brought into play. We presently have a 50% probability. Let's increase Jane's probability of inventions to 55% and draw. Now we only have a decision between Susan and Jane. Mary does not figure in this discussion. So, the important conclusion from this chart is that if the probability of Jane moves to 55%, Mary does not figure in the discussion. Likewise, what would happen if it drops to 45%? Let's clear chart. We still have a 3-dimensional problem. Let's try 40%. As you can see, this is the limit at which Jane is at play. Our 3rd dimension is right here. Under this scenario, we would only consider Susan and Mary. So this chart is extremely useful and is highly sensitive to Jane's ability to produce new inventions. If it's 40%, she should be counted out. And if it is 55%, Mary should be counted out. Susan is always a preferred candidate under both scenarios. This type of decision is not limited to recruitment only. It can be used in any scenario or even performance reviews. This is the end of this video.